Okay, so this time I'm using trigonometry to find missing angles. If you've already seen my other video that I've done on missing lengths, you've probably seen this page already. So with trigonometry, you need to be able to label the right angle triangle. This only works for right angle triangles. If it's not right angle triangle, you can't use this method. Okay, so we have to be able to label them. The first one's really easy. The longest side, which is also the side that's opposite the right angle, is called the hypotenuse. Okay. You've got two other options. You've got the adjacent and the opposite, and that depends on where this angle theta. Theta is just a symbol we use to be an angle. Okay, so depending on where that is, depends on where the opposite and the adjacent is. So this side is opposite that angle, so this side is called the opposite. And therefore this side must be the adjacent. But also the adjacent is in between the right angle and that angle there. Okay. Going on to this side, as you can see, theta, the angle has moved, it's over here. So that means that the hypotenuse stays the same, that's not a problem. But the opposite side is now this one. And therefore the adjacent, the one that's in between the right angle and the angle here, is now this one here. So the adjacent is this side. Okay. So just bear that in mind. Going forward, I'll call the hypotenuse H, the adjacent A, and the opposite O, just to speed things up. So let's have a look at an example. So if we have a look at this one here, here's my missing angle. I label the two sides that I've been given. So that's the hypotenuse, because it's opposite the right angle and the longest one. There we go. And this side here is opposite the angle, so that clearly is the opposite one. So again, you need to know your SOHCAHTOA. You might have different ways of remembering it. That's the way I've always remembered it. There's different things you can do, but you need to be able to remember that. Because if you've been given the opposite and the hypotenuse, have a look which one has the opposite and hypotenuse. It's this one here, opposite and hypotenuse. Once you know which one you're using, you can draw yourself a little triangle. And so you've seen this probably in science or with distance, speed and time. I'm using it with trig. So there's my sine theta, opposite and hypotenuse. Now if I'm after the angle theta here, I need to cover up this. That's sine theta, so I cover that up, which means I'm doing the opposite divided by the hypotenuse. So let's just write that down. Sine theta equals the opposite divided by the hypotenuse. So fill in what you know. Well, sine theta equals the opposite. The opposite over here was 3. And we're going to divide that by 7. I don't want to know that. I want to know what theta is. So I need to get rid of this sine on this side. Now to do that, we do the inverse. We do the inverse of sine. So that's sine, and the little -1 tells you it's an inverse. And then I do the inverse of that whole thing, 3 divided by 7. So how do I do that on my calculator? Well, it's really easy. Where the sine is, all you do is press shift and then sine, and you should see you get a little -1 there. Brilliant, that is your inverse sine. You've got an open bracket, so 3 divided by 7. Don't forget to close your bracket, and you get the answer. So theta equals 25.376, etc., etc. Again, the question will tell you to round the answer to 1 decimal place, 2 decimal places, whatever it wants. Obviously, just round your answer to what you need. Okay, let's have a look at another one then. So here's another question. Again, right angle triangle. We've been given two sides. There's my missing angle. Label what you have. Well, this side here is the opposite because it's opposite that angle there. This one here must be the adjacent because it's in between the 90 degrees and the angle I want, and that's obviously the hypotenuse. Don't care about the hypotenuse. I only want the A and O. Go back to your SOHCAHTOA, or A and O. I'm dealing with TOA. So draw yourself your little triangle to help you. So tan theta, opposite adjacent. And again, I'm after the angle, so I cover up tan theta, so it's opposite divided by the adjacent. So tan theta equals opposite over the adjacent. So fill in what we know. Well, tan theta equals the opposite was 8. And the adjacent was 6. And just like before, I don't want tan theta, I just want theta. So I have to do the inverse of tan. So I do the inverse of tan, so remember that little -1 there, and then it's 8/6. So I get my calculator, exactly the same thing. I do shift, and this time press tan. Don't forget to check it is the inverse. In the brackets, 8 divided by the 6. You're in business, because we have 53.130, etc., etc. And again, round it to whatever the question says you need to round it to. And the last example I have for you today is this one here. Again, we've got two sides, missing angle, label what we have. That's going to be the hypotenuse, because it's the opposite of the right angle and it's the longest side. This one here, well, there's the angle, so this must be the adjacent, because that one is clearly the opposite. So A and H must be the K. And again, draw yourself a little triangle. Cos theta, adjacent, hypotenuse. And again, I'm after the angle, so I cover up the angle, and I'm doing the adjacent divided by the hypotenuse. So cos theta equals the adjacent divided by the hypotenuse. Substitute in what we know. Well, cos theta, the adjacent was 9, and the hypotenuse was 12. Again, I just want theta, so I do the inverse of cos. So remember that little -1, 9/12. We grab our calculator, shift cos to get the inverse of cos, in the brackets, 9 divided by 12, close your bracket, press the equals, lovely jubbly, 41.40, etc., etc. Again, round it to whatever you need to round it to. So hopefully that helps, guys. Thank you very much.